Hello students, in the previous lecture we started describing the motion in terms of distance and displacement. I have used the symbol capital letter S for distance and the same letter capital S for displacement. Because usually small letter s is used to represent seconds, so we will be using from now on distance and displacement with capital letter S. In today's lecture, we will proceed further on the new topics. We will be learning about speed and velocity of the object whenever it is in motion. So, speed is a very common term which most of us are familiar with. It is used to describe how fast or how slow the motion is. जैसे हमने कछुए और खरगोश की कहानी सुनी हुई है कि कछुआ जो था वो थोड़ा धीरे चलता था, धीरे यानी कम स्पीड पे चलता था, और खरगोश वो फास्ट स्पीड पे चलता था. जब उन दोनों की रेस हुई तो अपने ओवर कॉन्फिडेंस के मारे जो रैबिट था he could not win the race, but still in terms of speed we can compare that the tortoise had a lesser speed as compared to the rabbit. So speed is usually used to describe how fast or how slow the motion is. Now let us assume one example. When I come from my home to the school, the distance between my home to the school is 25 kilometers approximately. But when I start from my home, I start at a zero speed. My car speedometer reaches 0. Then gradually my speed increases. Then जब भी कोई टर्न आता है तो मेरी स्पीड थोड़ी कम होती है. Then I take a turn. फिर मैं फिर से अपनी स्पीड को बढ़ाती हूँ. कभी ट्रैफिक आता है, मैं अपनी स्पीड को फिर कम करती हूँ. जो भी स्पीड में चेंजेस आते हैं वो सब स्पीडोमीटर मुझे रीड करके बताता है. लेकिन जब मैं ओवरऑल देखती हूँ तो 25 किलोमीटर का डिस्टेंस, 25 किलोमीटर डिस्टेंस कवर करने में मुझे हाफ एन आवर लगता है. तो अगर मैं टोटल डिस्टेंस को टोटल टाइम से डिवाइड करूं तो मुझे मेरे पूरे जर्नी की स्पीड मिलेगी. ऐसी वाली स्पीड को हम एवरेज स्पीड कहते हैं. एवरेज स्पीड मीन्स दैट द जर्नी, द टोटल स्पीड एवरेज ओवर द एंटायर जर्नी इज कॉल्ड एवरेज स्पीड. बट जैसे मैंने अभी आपको बताया, थ्रू आउट द जर्नी माई स्पीड केप्ट ऑन चेंजिंग. व्हेन आई टुक अ टर्न, whenever I faced a crowd, whenever there was a plain road, road was not crowded, then my speed was much larger. तो इस तरीके से कई बार स्पीड चेंज होती है. तो स्पीड चेंज होती है, जिस समय पर जो स्पीड को हम नोट करते हैं उसको हम स्पीड एट दैट टाइम कहते हैं. उसका एक टर्म होता है इंस्टेंटेनियस स्पीड, और जो पूरी जर्नी की स्पीड होती है उसको हम एवरेज स्पीड कहते हैं. तो यू कैन अंडरस्टैंड दीज बाय दिस फ्लो चार्ट, which is saying us that speed can be learned in two categories. One is known as instantaneous speed and the other one is called average speed. And as I told you right now that I can easily calculate my average speed by dividing total distance traveled by me with the total time taken. When I take the ratio of these two terms, I get the average speed of my whole journey. Remember what I told you about instantaneous speed? Instantaneous speed I can see in the speedometer of my vehicle. But how to calculate it mathematically? This you will learn in another branch of mathematics in your higher classes, which we call as differential calculus, or the overall branch is known as calculus. Here differentiation part will help you to understand how to find out instantaneous speed. In this class we will be majorly talking about the average speed. Now since we see that average speed is the ratio of total distance to total time, we can easily find out its unit also, in which unit average speed will be measured. If I take distance in meters and time in seconds, I get the unit as meter per second, or we can also write it as ms raised to the power minus 1. If I take the distance in kilometers and time in hours, I get another unit, kilometer per hour, which can also be written as kilometer r raised to the power minus 1. There is a conversion relation between meter per second and kilometer per hour, I suggest you to find out that relation to convert kilometer per hour into meter per second or vice versa. Another unit which we may use is if we measure the distance in centimeters and time in seconds, so we get another unit, centimeter per second or centimeter second inverse. So these are few common units which are used in the textbooks. In different numericals you will find these units which will be asked in the numericals. Next variable to learn is velocity. So velocity is speeding in certain direction. Speeding in certain direction का मतलब हम एक एग्जाम्पल से देखते हैं. सपोज एक साइक्लिस्ट है जो कि एक सर्कुलर ट्रैक पे साइकिल चला रहा है. This is the center of the circle. Suppose the bicyclist, he starts from some point A here and after some time he covers 1/4 of the circle and reaches some point B. So if we see the direction of its displacement, जिस दिशा में इसका displacement हुआ है, this is the line which joins A and B like this. ये line इसका displacement दे रहा है. अब distance जो है वो actual length of arc है A to B और displacement ये है. सपोज यहां से यहां आने में इसे कुछ 10 seconds लग रहे हैं, तो you can see that the length of arc is greater than the length of chord which is there, and this length in which the displacement is taking place, this length per unit time will give us the velocity. जबकि distance के केस में हम arc की length को time से divide करेंगे क्योंकि actually वो इसी रास्ते पर चला है. तो रास्ते की लंबाई को जब हम time से divide करते हैं तो हमें speed मिलती है, लेकिन एक्चुअल जो उसका डिस्प्लेसमेंट हुआ है वो A से B इस डायरेक्शन में हुआ है. तो अगर हम स्पीड को डायरेक्शन के साथ कंबाइन करते हैं तो हमें कुछ एक दूसरा पैरामीटर मिलता है, उसका नाम हमने रखा वेलोसिटी. तो वेलोसिटी इज नथिंग बट स्पीड इन अ सर्टेन डायरेक्शन. लेकिन अगर मान लीजिए मोशन, इफ द मोशन इज टेकिंग प्लेस इन अ स्ट्रेट लाइन लाइक दिस, सपोज द पर्सन इज मूविंग फ्रॉम A to B in a straight line, then in that case the distance and displacement will have the same value. Value मतलब magnitude. Magnitude same होगा. In this case, since the distance and displacement will have same magnitude, so speed and velocity also will have the same magnitude. Consider another case. Suppose the person, there are two people who are starting from some point A. One person reaches to point B which is 10 meters away. Another person also starts from point A, reaches some point C, which is also 10 meters away from A. If we ask what is the distance covered by the person B, B से जो distance travel किया है वो 10 meters है. C ने जो distance travel किया वो भी 10 meters है. लेकिन B का displacement plus 10 meter है क्योंकि वो A जो हमारा origin है, origin से right side में गया है. So he has covered a displacement of plus 10 meters और A से C लेफ्ट में जाने के कारण C का डिस्प्लेसमेंट हुआ है -10 meters. तो जब हम इनके डिस्टेंस के वैल्यूज को देखते हैं तो वैल्यूज आर सेम, डिस्टेंस एंड डिस्प्लेसमेंट दे हैव द सेम वैल्यू बट देयर डायरेक्शंस आर डिफरेंट, सो दे कैरी अ डिफरेंट साइन. सेम थिंग विल हैपन फॉर स्पीड एंड वेलोसिटी ऑल्सो. स्पीड और वेलोसिटी अगर सेम लाइन में है तो उनका मैग्नीट्यूड सेम होगा बट डायरेक्शन डिफरेंट हो सकता है. सो एज वी सॉ दैट स्पीड इज कैटेगराइज्ड एज instantaneous and average. In the same manner, velocity is also classified, or we can say that it is measured in two ways. One way is to measure the instantaneous velocity, the other one is to measure the average velocity. Suppose मैं अपनी गाड़ी से नॉर्थ डायरेक्शन की तरफ जा रही हूं और करंटली मेरी स्पीड 40 किलोमीटर पर आवर है, तो मेरी वेलोसिटी हो जाएगी 40 किलोमीटर पर आवर टुवर्ड्स नॉर्थ. उसको हम इंस्टेंटेनियस वेलोसिटी कहेंगे. और अगर मेरी स्पीड सिर्फ मैं मेंशन करती हूं तो दैट विल बी इंस्टेंटेनियस स्पीड. तो स्पीड विद डायरेक्शन इज नोन एज वेलोसिटी. आई एम रिपीटिंग द एग्जांपल वंस अगेन. सपोज आई एम मूविंग इन अ कार with a speed of 40 km per hour towards north, then 40 km per hour towards north is my instantaneous velocity. But Coming back to the average velocity will be my total displacement upon total time or total displacement per unit time. As we saw that distance and displacement both are measured in same units, so the different units for average velocity or instantaneous velocity can be kilometer per hour or meter per second or centimeter per second. Another important thing about speed and velocity is that speed is the ratio of scalar quantity with another scalar quantity. So speed is a scalar quantity, whereas velocity is the ratio of displacement and time. So this displacement part makes the velocity to be a vector quantity. And as I told you, to remember the thing very, very accurately, you should always remember that velocity is the combination of speed and direction. Let us look at this example to make some more understanding about speed and velocity. Here I have drawn a table which is showing the time lapsed in seconds and position of A with respect to the origin in meters and position of B with respect to origin in meters. A and B are two hypothetical objects which are moving, and time in seconds, you can see here that I have started the time from 0. Now what is this 0 time? This is very simple. Time 0 का मतलब होता है जिस समय आपने अपनी observation start करी है, that time is known as time equal to 0. This is 0 time. जिस समय टाइम 0 है उस समय पर आप देख सकते हैं कि ऑब्जेक्ट ए और ऑब्जेक्ट बी बोथ आर देयर एट द ओरिजिन इटसेल्फ, दोनों ओरिजिन पर ही हैं. देन आफ्टर 5 seconds ऑब्जेक्ट ए रीचेज एट 10 meters अवे फ्रॉम द ओरिजिन, ओरिजिन से 10 मीटर दूर जा रहा है, और ऑब्जेक्ट बी भी 5 सेकेंड में 10 मीटर दूर जा रहा है. तो इस पर्टिकुलर टाइम सेगमेंट में आप देख सकते हैं कि दोनों की स्पीड सेम है, बराबर स्पीड से चल रहे हैं. Coming to the next time interval, we see that object A moves from 10 to 20, that is another 10 meters in 5 seconds, whereas object B travels only 5 meters in this 5 seconds. So we can see that object A is faster here as compared to object B. In the next time segment, we see that object A again travels 10 meters, whereas object B also travels 10 meters. It means that object B has speeden up here. Next time interval between 15 to 20 seconds, object A travels 10 meters and object B travels by 15 meters. So he is faster here, object B. So in the entire case we see that object B is not having a constant speed. Its speed is changing. Sometimes it is lesser than speed of A, sometimes it is more. Even if we don't compare the speeds of A and B, still we see that object B is having a non-uniform speed. And suppose the motion here is taking place in a straight line which is not mentioned in the table. So in the straight line motion, speed and velocity can be taken to be same magnitude as I have told you before, because distance and displacement will be same. So in these tables, we can understand the concept of speed and velocity, that speed can be measured for each time interval. Along with that, another important concept comes out is that object A is showing a kind of motion which is known as uniform motion. Uniform motion means the speed remains constant and the motion remains to be in a straight line. I am repeating once again, uniform motion means constant speed and the path is a straight line, whereas for object B, the speed is not constant, although the path is a straight line. So object A is executing uniform motion, object B is not executing uniform motion. So for uniform motion, what are the two essential components? One is speed should be constant and another component is direction should be a straight line. We can also say that the path should be a straight line path. What do we say about motion of a fan moving at a constant speed? The fan, although it keeps moving on a constant speed, but since its path keeps on changing at all the points, any rotating object which moves, suppose the blade of the fan is here at some time, after some time the blade moves to some other direction, some other time it is at some other direction, and so on. So direction goes on changing for the fan of a blade, therefore the direction keeps on changing. So it's not an example of uniform motion, but it is a non-uniform motion. So uniform motion can become non-uniform by changing the speed of the body or by changing the direction of the body. Another important thing which I skipped in the entire thing, that velocity will have the same direction as that of displacement. Remember that velocity ka direction or displacement ka direction will be same. And I have used velocity के लिए symbol मैंने u और v यूज किया है. u का मतलब होता है initial velocity, v का मतलब होता है final velocity. मतलब जो समय जिस टाइम पर हम ऑब्जर्वेशन कर रहे हैं, जिस टाइम पर भी हमारा ऑब्जर्वेशन का टाइम है, उस समय पर जो इनिशियल पहली वेलोसिटी है उसको इनिशियल वेलोसिटी कहते हैं. उसके लिए सिंबल u यूज करते हैं. और बाद में जब हमारा ऑब्जर्वेशन खत्म हो जा रहा है, तब जो लास्ट वेलोसिटी है दैट इज नोन एज फाइनल वेलोसिटी. पर वेलोसिटी का डायरेक्शन हमेशा डायरेक्शन ऑफ वेलोसिटी इज ऑलवेज द सेम as direction of displacement. This is something very important. इसको हम आगे भी काम में लेंगे, तो इसको आप